Hello everyone, my name is Fuyuhiko Tanaka, and today and next week I will talk about Bayesian prediction methods and its application to quantum information. Now let's begin. In part 1, today we will make a brief review of Bayesian statistics in section 1. And then, in section 2, we will see the concept of predictive distributions, and then consider the basic concept of Bayesian prediction. And finally, in section 3, we consider how to evaluate predictive distributions in a statistical sense. Now let's begin with the review of Bayesian statistics. Okay, first we see some notations. First of all, we introduce a statistical model. A statistical model is a parametric family of probability densities or probability distributions, which is denoted by, in this talk, P of x given theta. Theta is an unknown parameter theta and specifies a certain probability density. So the integral over the data space x is equal to 1 and P of x always non-negative. And we often write x tilde P of x given theta. It implies the observation x is distributed according to a probability distribution, P of x given theta. Here we often confuse probability distribution with its probability density. And we often use IID. It implies independently identically distributed. For example, from y1 to yn, whole observation is independently from this probability distribution. Okay, let's go to the next. Now let's introduce prior distribution. This is a starting point of Bayesian statistics. For a given statistical model, we introduce a probability density of the unknown parameter theta, which is denoted by Greek symbol pi here. Pi of theta, which is a probability density of theta. And we call this probability distribution a prior distribution, or shortly, prior. And it represents the uncertainty of the parameter for us. This is a starting point of Bayesian statistics. So we have one probability distribution for observation x and the other probability distribution of the parameter theta. Next, formally, we introduce a joint distribution of x and theta, which is defined by a probability distribution multiplied with prior distribution, px given theta times pi of theta, which is actually interpreted as a probability distribution of x and theta. Then we obtain a marginal distribution of x, which is denoted by P of x. And automatically, we obtain conditional distribution of theta given the data x. Again, we use the symbol pi for this conditional distribution. Pi of theta given x is calculated by this formula. This is actually the Bayes theorem. And we call this conditional distribution of theta given x posterior distribution or posterior density, or shortly posterior. In Bayesian data analysis, we have to set a prior anyway. And here we consider how to set a prior distribution. And first of all, theoretically, there is no universal way or no machinery to determine the best prior distribution. But we have basic strategy for real actual data analysis. The first one, we often use a uniform distribution over the parameter space. And we often use some distributions like normal distribution with sufficiently large variance. This is the first one. And the second one, we use a good partner who gets along with a specific statistical model. As we shall later see, a good combination of statistical model and prior distribution makes calculation of the posterior very easy. This is the second one. The third one, if we additional information on the parameter space, then we use a certain kind of prior information. According to this information, this kind of prior distribution is called a subjective prior. And here we briefly see the second one. Okay, now let's introduce conjugate prior. Choosing a good combination of statistical models and priors enables us to calculate explicitly the posterior distribution, even if it requires some calculation of integration. And this kind of prior is called conjugate prior. Here we only see typical examples of conjugate priors. And if you are good at math, it's better to calculate each example by yourself. It is a very good exercise. Now, in the next slides, we have 3 examples of conjugate priors.